Okay, let me talk a little bit about inflection points. So if we take a look at this function right here, part of which is in orange, part of which is in blue, it has the equation 0.9x to the fourth plus 1.6x cubed minus 2.2x squared minus 0.4x plus 2.3. We also have this line here, the tangent line, that is tangent to the curve at that blue point. So one of the things you can notice is I move this tangent line by moving this point, and you take a look at the slope of the tangent line, you can see that as I'm moving it, the slope is increasing. In this case, it's negative, it's getting closer to zero, and keeps increasing all the way up to it reaches this point. But where the function turns blue, this is where the slope starts to decrease. And as we track it around, it continues to decrease until it reaches this point B, where it again starts to increase. So the places on the curve where the tangent is increasing as I move left to right are marked in orange, and those where it's decreasing are marked in blue. The orange portions of the curve we can consider to be concave, whereas the blue portion we consider to be convex. The points that separate these regions, orange and blue, points A and B, are called the inflection points. And basically, it is where the slope of the tangent line shifts from increasing to decreasing or from decreasing to increasing. Now, not every single curve is even going to have both. In this case, for example, we only have orange because we only have the concave, we do not have the convex. And so as we watch, we can see that these things will start to change, and some functions will have both regions, some will not. If I had a more complicated function, I might have multiple blue regions instead of just one. But again, as we move this around, we can see that the slope is decreasing, 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 but here at point B, it starts to increase. And then as we shift around, it keeps increasing until it reaches point A, at which time it starts to decrease again. So again, these are called the inflection points, and it's important to distinguish those from what are called local maxima and minima. So the point right here, where going between, let's say, x is -2 and x is +1, this would be the maximum value in that interval. That's a local maximum. This point right here, which would be the minimum point between, let's say, x is equal to, well, actually x is 0 up to infinity. This is called a local minimum. It turns out to be the absolute minimum for the function as a whole. But if we look at this point right here, where the blue point's located currently, that point is a local minimum. In other words, it has the lowest value between, let's say, x is equal to -3 and x is equal to, well, certainly, let's say x is equal to 0. So that's considered to be a local minimum. But these points are different from the inflection points, because these are not the points where the slope of the tangent is going to go from increasing to decreasing or decreasing to increasing. It's where we're going to find a local or absolute minimum or maximum for the value of the function. So it's important to be able to distinguish between inflection points and local maximum and minimum points.